Hello, and welcome to the 13th video in this video series of using Godot with the Rider IDE and C# to create and modify a 3D mesh. In the last video, I thought that I fixed the problem of being able to select the triangles if the cube was rotated, and it appeared like it was fixed for that particular case. But then a commenter found out that if you translate the cube and then you try to highlight a face, it won't work. And I'll demonstrate that, and I'll walk through some print statements I used for logging to figure out what was going on, and then I'll present the solution because there's a little bit of vector math that we need to be clear on. So what we had going on here is the problem before is if we rotated the cube, let's say by 45 degrees, and then we ran the game, we couldn't select the face, well, a face, but that appears to be fixed now. And the way that was fixed in the last video was that when we were getting the face normal, I wasn't pushing it to the global/world system, so the angle math was all off. And that seemed to fix it for that case, and for that case it did fix it. However, let's undo the rotation here. If we just offset this cube by, let's say, -2, so let's scoot it over just a little bit. Let's make it -5, actually. Make sure it's over far enough to demonstrate the problem. And now, if I try to select faces, it's not going to work. Click, 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 click. So it's like, well, what's going on here? Well, after a lot of, after some trial and error, I was able to, with a bunch of logging, figure out what the issue was, and it was a bad assumption on my part. Let's put some logging into the program, and then we'll run the game, and then it'll become clearer what the problem is. So when we let's introduce some code just when we're in the intersects triangle, just for some logging. So why don't we do a few things here? Why don't we create a variable for the global cube center? And that's going to be, go to the cube mesh instance, go to the global transform, and you get the origin. And then for another variable, let's pull out that I guess we'll call it local normal for this particular face. And the local normal is this. So we will do the copy paste. And then let's go ahead and let's do another variable. And let's call this one global normal. And this is going to be the cube mesh instance .to global of the local normal. All right, and then so let's put some prints in here. Well, first, let's just change this over so that this is using that variable that was signed up there, because we're gonna keep these variables in place. I wonder if that'll fit now on the line. It does. All right. Okay, so let's add some print statements here to kind of use for debugging. So let's say something like cube's center is, and we'll go ahead and do the global cube center. And then let's go ahead and log the we'll say face index, because up here is where we're checking each of these faces. Face indexes local normal is, and we'll do a local normal, and we'll do a GD print, and we will say face index plus face indexes global normal is, and we'll do a global normal here. And that should be it. Oh, we could put the angle in there, but I don't think we need to put listing the angle because it'll become clear here what's going on with these print statements. All right, so let's go back to Godot. Let's go ahead and put this back at 0. In fact, what we're going to do for this, let's shut the floor off so we don't have the floor so that we can move things down if we need to demonstrate or at least test something. And remember how we lifted this to 1.356? Well, let's just for right now zero that all out. Okay, so let's run the game now. And now if we run the game, and then we're going to click on we'll just click on the front face. Okay, so let's close this up. So what you're going to see here is you're going to see the cube center is at 0, 0, 0, which it definitely is. The zero's local normal is 0, 0, 1, which it is. It's the little white line was pointing out toward us. And the zero's global normal is 0, 0, 2. Well, the reason it's a 2 is remember when it's facing the right direction still. It's still positive z with no x and y's. But if you remember, we scaled up we didn't scale the cube here, but we created the mesh instance and we scaled it up. And so I believe that's why we're getting the 2 here, is because of that 2 scale. Let's go back to the code. I think that would be the I thought it was create and assign cube mesh. All right. Yeah, so remember the reason we did this was because in Blender, when we were using the Blender cube is actually 2 wide. Each extent is 1 in each direction. And when we set up the cube in here manually, everything was just 0.5 extent, so the cube was only 1 total width. So we just scaled it up so it would be the same size as the Blender one. And I believe it's the scaling, which is why when you compute the global transform of that normal, it doubles it. But that's fine. I mean, it's still pointing in the right direction. And I guess we'll demonstrate. We'll move the problem. You'll see what's happening with the problem, and then I'm going to do a little bit of whiteboarding here as far as talking about vector stuff, and then we'll put the fix in. The fix is actually pretty easy, but it was a difficult one for me to figure out what was going on there, because if I would have known about this, I would have fixed it earlier. So let's scoot the cube over that -5 again, and we'll play the game. Let's click on that and then exit. All right, so what we're seeing here is there were 2 candidate faces that the purple arrow intersected. It intersected face 3 and face 11. And so if we look at our code, let's make sure we know what face 3 and face 11 are. All right. So 0, this line is 0, 1, 2, 3. So the first thing it checked was the backside to see if it intersected. It did intersect, but then we had the angle. We were going to check to see if the angle is there. So 4, 5, 6, 7, 8, 9, 10. And then here we have 11, which is the right side. That's the one that we were going to hit if the angle was being computed correctly. So we're interested in the logging for the right side because that's the one we care about. So if we go back to Godot, and so we're just interested in from this line down. So the cube center is at -5, 0, 0. Yup. The local normal is pointed at 1, 0, 0. Yup. Because the normal would be pointing in this direction, and this is the positive x. Global normal is at -3. Well, wait a minute. That's pointing in the other direction. What's going on here? Well, we have to talk a little bit about vectors to know why that is. And like I said, this is this was an assumption that I made that I shouldn't have made, because what I assumed was going to happen was I assumed that when I did this, the cube mesh instance to global, the local normal, that it was going to give me the local normal translated to global, and it doesn't actually do that. What it does is it takes the I guess we'll call it the endpoint of that arrow, and it goes ahead and translates that in the global space. But if we leave it as is, it's connecting it back to 0, and we don't want that. And it'll be easier to show on a whiteboard. So if we bring up the whiteboard here, so we're going to do this in 2 dimensions, just x and y, but it's the same thing for z. It's just easier to show in x and y. So if we have how can we draw it in here? Yellow, I guess. So if we have a vector like this, and let's say we're drawing it in this direction, and let's say this is at 2, 0. Okay, and that's with its tail of the vectors at 0, 0, and the arrow, the very end of the arrow is at 2, 0. Now with vectors, I guess I don't know if I ever gave an explanation of a vector. There's more formal definitions, but let's do that first. So a vector one can think of as just an arrow, and the arrow has a direction and it has a length. So despite my crappy drawing here, let's pretend these are both pointing in the same direction. So these vectors are both pointing in the same direction, but they have a different length, or as they call it, a magnitude. So the 2 things we care about with vectors are the length and the direction. Now for angles, we don't care about the magnitude. From a angle point of view, whether it's this long or this long, it's still the same. It'll give us the same angle. So what we need to remember here is there's a tail and an arrow here. The head, I guess, the head and tail. So let's go ahead and remove this. Can I make this bigger? Make it bigger than that. Yeah, that's better. Okay. So let's go back to what we drew here. So we drew an arrow starting at 0, 0 and going to 2. Now let's draw another arrow here. Oops. Apparently it changes it for whether you're racing or you're, let's put it back to 10. So let's start at here, put the tail there and go here. So let's say this is still at 2, 0, and this is at 4, 0. All right, these 2 vectors are the same vector because they have the same direction. They're going 2x, no y, and their magnitude is 2. So these 2 vectors are the exact same vector. It doesn't really matter where the tail starts for vectors. However, we probably do care, in fact, I know we care about, well, okay, sure, the vectors themselves are pointing in the same direction and at the same length, but, I really care where this, this head starts. Well, yeah, this is the head, tail, head, tail, maybe. I guess they'll call this the head. Well, they'll call this the base, and we'll call this the arrow. So we really care where the base is at, as far as where it's offset in space, because this arrow, from our point of view, isn't the same as this arrow. Well, why is that? Well, this is where it gets kind of interesting. So this base here starts at 0, 0, right? So there's really, from the origin to this base, there's no arrow. However, the origin of the world that we're looking at here to here, that's a vector. That's a vector of 2, we'll pretend this is 2 up. So this vector here is 2, 2. So, the question will be, well, why does that matter? Well, because when we're talking about angles and normals, if we go back to Godot here, when we have this initial normal, 11's normal, that is 1, 0, 0. So it's going in this direction, 1, 0, 0. When it's, let's put it back to 0. When it's here, it's going, I think I can turn on. When it's at 0, 0, it's going this way. This local normal, this is at 1, 0, 0. All right. Well, what happens when I move this over 10 or 5? I guess it was -5. Well, what happens there? Well, this 1, 0, 0 is the arrow point here, right? So when we call that to global, what it's going to do is it's going to give us the where this arrow point is again. So let's pretend. Oh, I don't have to pretend. Let's put them back there. There is 0. Oops. There is 0. And then let's go -5 again. So when we say, okay, this 1, 0, 0 local normal to global that cube mesh instance, and it comes back with -3. So it's going to give me this -3, which is, let's just pretend it's here. Oops, turn on. Let's just pretend it's here. Well, if we draw a vector between the origin and that, we're going to get a vector like that, right? Well, if we do nothing else, that's all to global did, is it made an arrow. It said, look, you gave me this 1, 0, 0 point here, the end of the arrow. You said to global it so that I take my cube mesh instance transformation into effect. Okay, well, I'm telling you that when I do that, I'm going to get a -3, 0, 0. So there's a point there. Well, if you just leave it at -3, 0, 0, if you go back to our whiteboard, well, what is -3, 0, 0? Well, as it showed on that graph there, -3, 0, 0 is something like this. Well, that's in the exact opposite direction of what I wanted. Scratch head, what's going on there? Well, what we want, can I erase this? I cannot erase that. How does one erase? Oh, we'll do that. So what we would like is, let's say this is the origin here. And then this is that -3 thing. What we would like is we would like the arrow to start, let's say, here. I mean, technically we'd want it to start at the face here. But let's just start at the center of the world here, or the center of the cube. We'd want the base to start there, and for the tip of the arrow to end at that -3, 0, 0. If we do that, then this normal is going to be facing the same direction as what it was before the translation. So what we want to do is, after that to global, all we're getting is the tip of the arrow, and then we want to create a arrow from the center of the cube to that point that the global normal, the to global, gave us back. And if we remember, if you have, let's go to a web browser. If you look at the Godot has a nice page on vector math. So in this case, you have a tank here, and then you have a robot. So that's these two blue vectors. And then the question is, well, what if I wanted a vector where the base of a new vector is starting at the tank and then is going to the robot? Well, the way you do that, if you have a tank that's A, and the destination, the head of the vector is this robot B, well, you just do the destination, which is B, the robot, minus where you want the point to start. And that'll give you the vector in the right direction. So we actually have to compute that ourselves for this normal. So just remember, to get a vector, it's going to be destination minus origin. Let's just call it that. So if it's destination minus origin, then if we go back to, that's interesting. I thought I shut off the annotation tool. Okie doke, I guess I didn't. So this global normal is that point, but we actually need the point, the tip of the arrow, but we want it to go from the cube center to the global normal. That's going to be our new normal. So let's just call this new global normal. And what it's going to be is it's going to be the destination. Well, the destination is that global normal. And minus, well, what's the beginning of that arrow? Well, it's going to be the global cube center, right? So this new global normal is the new normal we want to check against. That's been offset to where we want it. So before we do any logic with the computing the angle with that, let's just go ahead and log that. Call it the new global normal is new global normal. All right, so let's go back to Godot. And we're already still offsetted by -5, so let's start the game up again. And we're looking for face 11, so that'll be the second part of the log there. So click in there. All right, let's look at the log here. So again, we only care about anything below here. So the local normal is 1, 0, 0. So you want it pointing with no y and no z in the x direction. Well, the new global normal is -3. Well, that new global normal that we computed is got a positive x. That's exactly what we want. Now, granted, it's got that 2 there because of the scale up, but like I said earlier, we don't care about that. We only care the direction. When you compute an angle, the magnitude of a vector, the length of a vector doesn't factor in. You only care about which way it's pointing. So just by doing that, we have a solution here. So what we can do is go back to our code, and we're computing the angle instead of doing it with this 2 global local normal. Well, why don't we just do it with this new global normal vector? And that should give us a normal vector pointing in the correct direction that takes into account the offset so that the normal is still pointing in the right direction. So if we fire up the game now, and we'll try this in different scenarios, we should be able to get our face highlighting happening here. All right, click here, highlight, 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 highlight. Hey, that's looking pretty good. All right, let's put this to where the commenter actually found the problem. So let's move it up 10. So we'll play the game. And I'm going to use the control key and back out since the cube's actually above us. All right, let's try clicking on the bottom face here. It highlights the other bottom face. It highlights this one, highlights this one, highlights. Let's rotate, oops, wrong key. Let's rotate a bit. How about this one? Yup, how about this one? Yup. All right, let's go -10. Let's start the game. Back up just a little bit. I'm going to click on this top face. It highlights this one. It highlights the front face. Highlights this face. Highlights. Rotate. This face. Highlights. This face. Highlights. Let's look at the back. This one highlights. This one highlights. Let's look at the other one. This one highlights. This one highlights. So let's put this back to where it was. Well, actually, let's try something different here to say, okay, well, let's rotate this by 45 degrees and rotate this by 45 degrees. And does this still work? So we're not only have we translated up 10, we're rotating by 2 axes. And let's see if our new math holds up to that. Let's back out a little bit. Clicking here, works. Clicking here, works. Clicking here, works. Clicking here, works. rotating a bit. Clicking here. Works. Clicking here. Works. Clicking here. Works. Clicking here. Works. So from what I can tell, the math works here. Let's offset not only 10 up, but let's do negative 10 or negative 10 down. Let's do 10 over. So now we're translating by 2 axes and we're rotating by 2 axes. Let's see if it still works. Let's back out a little bit. There we go. So let's click the top face here. Works. The other top face. Works. This face. Works. This face. Works. This face. Works. This face. Works. So there's a solution. So let's put this back to where it was. So we're going to remove the rotations. We're going to remove the translations. And this needs to be at the same level as the camera helper, which is at 1356Y. Put the cube at 1.356, oops, 1.356Y. And let's turn the floor back on. And let's just make sure our simple case still works, which it should. Bam, 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 bam. Looks like it works. So hopefully that makes sense what I did there. I'll go back to the code here. So we have to, well, let's go back to the web page. I mean, we have to, when we run that toGlobal, this is, I'm restating, I guess, I'm summarizing what we did here. So when that toGlobal comes back for that normal, it's going to give us the tip of the arrow. And if we don't do anything, the tip of the arrow is just going to be a vector from the origin to it. Well, we don't want that. We want something like this, where we have, in this case, this would be analogous to the cube center. This here would be analogous to what that toGlobal return for the normal. So then we have to do and create a new vector. So what we would do is this B minus A, destination minus source. And that's why the vector here, we did the math here, this new global normal. So this local normal points in a direction. We run it through the toGlobal grinder here, and we get that tip of the arrow translated, and then we have to create the arrow from the cube center to the toGlobal tip of the arrow, and then we run the angle on the purple arrow, which is the test vector, and then we do the angle to the new global normal because that's what we want. And we can get rid of this logging now because we don't need it anymore. And that's the solution here for this. Now, technically, I mean, we can get away with this because we're using a cube, and the cube, you know, is the sides are like perpendicular to the axes relative to the center. But if we had a more complicated setup, like if this top face was like rotated 45 degrees, we couldn't just draw the arrow from the cube center to that new toGlobal. What we'd have to do is actually start at the face. We'd probably want to compute the center of the face and then draw to that toGlobal normal. And we'd have to take some offsetting into account because like what if when offsetted the normal, well, I won't get into that. If we did it that way, we'd have to do a little bit extra math to make sure that we're not inside the cube, so that we're not flipping the normal backwards. But we're not, since the cube is such a simple shape, we can get away with just saying draw from the center and then draw to the new toGlobal point. So I'm hoping that this makes sense. And thank you for the commenter for finding an issue with what I did, because it surprised me, and I'm learning this as I'm going along. So this was a nice educational route for me to go down. So anyway, I'm going to end the video here. And hopefully this is the final solution for this, because you know, I thought I had the final solution last time, and it turns out I didn't. But that's okay. I mean, I actually like learning this stuff. So the fact that I had to, you know, think about, well, why didn't this work? That was actually a fun thought experiment to figure out why that wasn't working. So anyway, thank you for watching the video, and I'll talk to you later. Bye-bye.